Okay, so we are ending our last section or lesson of these specific notes. And what we're talking about today is combinations. So what we're learning, this is the beginning of our probability unit, right? And what we're learning in the beginning of this probability unit is how to figure out how many options we have, right? If we're trying to find the probability of something, we say, well, what's the probability of this event occurring out of the total number of possible options? And so with this fundamental counting principle, permutations, and combinations, their main point is to get you to determine how many possible options are there for this situation, right? Like if you were to apply to be on the board of the grade 10 student council and you applied for it, and out of the total number of your classmates, only 5 of you will be chosen. Well, what's the amount of circumstances, or how many circumstances exist for there to be 5 people chosen randomly or not so randomly for this board? And then you figure out how many total possible options of permutations, or in this case combinations if there's no specific spot. And then you can say, well, what's the probability that I am going to be on that? And then you can then take the total amount of possible combinations you can make and then add you into that equation to figure out the probability. So all of this is a very long-winded, and I'm not sure if necessarily helpful way of explaining that we are figuring out total number of possibilities here. And then our next lessons are going to be talking about the probability using these total number of possibilities. So when Mrs. Terabelli started making her list of top 3 Mario Kart characters, like we talked about with Mr. Shantz and Mr. Coelty, she became frustrated with the whole process. She argued that she should not be forced to rank these characters, but rather just choose 3 characters that she would play or we would play out of the total 8. How many different groups of 3 characters can be chosen? What's the difference between ranking top 3 characters and just choosing top 3 characters? So what's the difference between ranking them of first, second, and third, or just picking 3 randomly? So, for instance, if we were picking top 3 and we were picking we picked, let's just do Mario, Luigi, and Peach. So we could do Mario is first, and then Luigi, and then Peach in terms of ranking, or Mario, and then Peach, and then Luigi would be a different ranking, right? In this case, Peach is the second best, and Luigi is the third best. Or you could do Peach first with then Mario and then Luigi, or Peach and then Luigi and then Mario. Or you could do Luigi first and then Mario and then Peach, or Luigi, Peach, and then Mario. So with that, it's still the exact same 3 characters. You're just changing which order they move around in, which is first and then second and then third. But with combinations, like with this one, all 3 of those options would be the same option for Mrs. Terabelli's option for this. She would say those 3, I would just pick those top 3. I wouldn't have to necessarily rank them. They would just be my handful of 3 characters that I use every time. So combinations says that the order does not matter. So just picking a group of people, and no object is used more than once. In other words, repetition is not allowed. So the formula for this guy, how we write it, first of all, is n choose r, right? So n is still the number of total possibilities, and r is the number of spots we have available. We also write it in this type of format with n over r. If you see something like that, that is a combination notation. The formula is very, very similar to our previous one, where we have n factorial over n minus r factorial, but we have to divide out the fact that these 6 different options up here are really actually the one same option for combinations. Whereas permutations, these are 6 very different choices. With combinations, those are just one choice. And we're dividing out the 6 different possibilities under the one choice of 3 characters. In other words, we need to divide out the extras there. The extras will always be your number of spots. So in this case, 3 factorial. So if we're dividing out those 6 options as different ones and just making them 1, we're going to divide out 6 from this permutation number. So instead of it being that, we would divide out r factorial as well. So the number of different options there would be 8 choose 3, and 8 choose 3 would be 8 factorial over 3 factorial times 5 factorial. You can do a little bit of, you could plug this into your calculator, or you can do a little bit of thinking here. If 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 5 times 4 times 3 times 2 times 1. You can cancel things out. These are all being multiplied. And so I know that the 5, 4, 3, 2, 1 would cancel out. 3 and 2 would cancel out with 6. And then all that's left then is 8 times 7, which is, because 3 times 2 is 6. What would cancel out with the 6 on top, in case you didn't follow? 56 different options. As opposed to our last lesson, the number of options that we had was much higher, 336 different ways of ranking it. Instead, we divided out 6 from that and got 56. Choose is in the same spot in your calculator as permutations. So if you go to menu and then probability, you'll see permutations, and underneath it, you'll see combinations. Okay, Julia has decided to grow some plants on her balcony. I don't know if Julia has a balcony, but in this problem, she does. She has decided to grow some herbs and flowers. There are a total of 25 different plants to choose from, but she only has 4 different planters. Given that she doesn't want to put the same plant in 2 different planters, how many different groups of plants can she create? So there's a few things here that I made clear in this problem to make sure that you knew that this would be a combination, that you can't choose the same plant to be in 2 different planters. Also, we're assuming that 1 planter will hold 1 plant. So we need to pick out 4 plants from the options of 25 different plants, but there's not a specific order. I'm not saying that like, what are the possibilities for orderings of plants here? We're just saying, what are the different plants? So we're pulling out a group of plants, but not specifically putting them in this planter and then this planter and then this planter and then this planter. So that's the difference between permutation and combination, is that we've got no specific order here. So this would be 25, choose 4. I don't know why combination has the word choose and permutation doesn't have one, but that's what it is. You can use the formula or use your calculator. Oops. 25, 4. There are 12,650 different groups of plants that she could create from just a total of 25 options, which is crazy. Okay. ASM Student Council has 8 freshmen, 7 sophomores, 7 juniors, and 9 seniors. They would like to send 3 freshmen, 3 sophomores, 4 juniors, and 4 seniors to an event. How many different ways can they do this? So this one is tricky because it almost seems like a fundamental counting principle problem, because we've got different spots, and for each spot we have different possibilities to pull from, right? So like when we're making a meal, as we did with at the very beginning of our notes, when we're making a meal, we have 3 different things that we need to get. Maybe we need to choose an entree and then a side and then a dessert. Well, we have a certain number of entrees to choose from, a certain number of sides to choose from, and a certain number of desserts to choose from, and they don't cross borders typically, right? I mean, I guess you could choose a dessert for all 3, but I'm pretty sure your mom would get mad at you. So you have to choose one from each specific pool. Here we have that, except for we need to choose 3 freshmen from a pool of 8 freshmen. We need to choose 3 sophomores from a pool of 7 sophomores. So actually, since we're choosing more than one option, the idea of your pool shrinking as you keep pulling from it, which is where the factorial comes in. The factorial comes in because you pull one out for one option and now you have 1 less than you had before. And then you pull another one for another option and now you have 2 less than you had before. So that's where this idea of multiplying sequentially down comes from with factorial. So the same thing's applying for each grade level. So what we're actually doing is we're finding combinations, not permutations, because there's not a first place freshman, a second place freshman, and a third place freshman. We're just pulling 3 freshmen out of the pool of 8. So it's combinations for each 4 grades. And then we figure out how many options for each 4 grades. And then we have to multiply each of those together. So this seems like a fundamental counting principle, but since there's more than one choice for each spot, the freshman spot has 3 choices, right? Then it's actually a combination for that. And then we have 4 different combinations we have to do. So to recap, we have freshmen, sophomores, juniors, sophomores, juniors, and seniors. And the combinations for each of them go, we have a total of 8 freshmen, and we're choosing 3 to go. We have a total of 7 sophomores, and we're choosing 3 of those as well. We have a total of 7, oops, that's a really big 7. 7 juniors, and we're choosing 4. And then we have a total of 9 seniors, and we're choosing 4 of them to go as well. So then 8 choose 3, which we did up above. 56, is that what it was? Yeah. 56, and then 7 choose 3 is 35, and then 7 choose 4 is 35, because 3 plus 4 is 7. So the possibility of you picking 3 and leaving 4 behind is the same as picking 4 and leaving 3 behind. It's just the different side of that probability. And then 9 choose 4 is 126. So we know what each of these different possibilities are. And then with each of these possibilities, with the 56 different possibilities, I have 56 different possibilities compared to the 35 for sophomores, compared to the 35 for juniors, and then 126 for seniors, right? So if I chose one way for freshmen, there would still be 35 different ways for sophomores, 35 different ways for juniors, and 126 different ways for seniors, right? For just one of the choices of freshmen, which means that now this is where the fundamental counting principle comes in. We've got 156 options for one slot, 35, 35, 126, and we just need to pick one of those options for each. So we multiply those all together, times, 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 and that equals a pretty big number. 643,600 possibilities. All right.